Hi, welcome to this tutorial. My name is Mehdi Saleh, and in this tutorial we are going to create Octopus leg. In this tutorial we are going to take advantage of procedural modeling inside Houdini to create this tool, and as you can see we have many controls over our model here. For example, we can change the resolution of the leg, we can go to the higher values or maybe to lower values, and here we can twist our model, and also here we can change the direction of the leg. We can rotate this side of the leg. Okay, and here we can determine the level of the subdivision of our model, and we have a seed value here to introduce some randomness to our model. And of course, as you can see here, we can change the thickness of the cross section with the help of this ramp. And finally, we can create our own curve. Okay, for example, this curve, and we can connect it to our tool, and this tool creates an octopus leg based on this input curve. As you can see, we have lots of fun in this tutorial, so let's start with the clean scene. Okay, and let's create a geometry, dive inside and delete the default file node. Let's create a curve. Okay, and let's add a convert node and convert this curve to the nerves curve, so we have a smooth curve here. And let's add a resample node to increase the number of the points along this curve. And let me choose a higher value for the length, for example 0.5, and let's create a cross section for the leg. And here I will use something like this. Okay, Okay, and here we can add a sweep node. Here the first input is the cross section, and we can use our sample node as the second and third input. Okay, and here let's rotate our cross section, and also let's use the roll option for better alignment. And here let's choose a skin unclosed option for a skin output. Okay, and here we want to decrease the thickness of the leg along the curve length. So let's create a null here and go to the edit parameter interface and create a float ramp. Let's rename it to cross. Okay. And here let's create whip attribute. Let me rename these nodes to something more meaningful. Name it to something like cross ramp. Here we can use channel ramp expression to access the value of this ramp. So let's type here channel ramp and here the name of this node. Cross ramp slash cross. Okay, and the position of the ramp is number of the point divided by total point number. Okay, and if I go to the geometry spreadsheet, you can see here we have whip attributes. Okay, based on this ramp. Okay, and now we can use the width attribute inside the sweep node. So here for the scale value we can use point expression to have access the width value. Okay, and you can see the result here. And now we can adjust the thickness of cross section along the curve. And now it's time to model the suckers along this tentacle. So first of all, we have to select these faces at the bottom of the tentacle. So let's see the number of the faces. Here you can see it starts from 2 and also 3. 2 plus 5, which gives 7. 7 plus 5, which gives 12. And we can select the faces at the bottom based on their numbers. So let's create a group node. And here we have to select group by expression as the operation, and here we can type if $PR modulus sign 5 is equal to 2, or the remainder of the division of primitive number by 5 be equal to 3. Be equal to 3. Okay. And let's rename it to suckers group. And here also let's name the group sucker. And now we can use poly extrude node, and we can use suckers as the group. Okay, and we can extrude these faces, and we don't want to merge the result together, so let's select no for keep points shared. And here, as you can see, we need more divisions, and we need more divisions at the end of the leg, because you can see the length of this face is higher than the width, and you can see the portion of length to width is very high for these faces. So here we cannot use the resample node alone, because as you can see, resample node divides the curves to equal segments. So here what I'm going to do is to create a color attribute for the curve. Okay, and here I want to be sure that the value of the red color is not 0 for any of these points. So I add 0.01 to this value. Okay, and for better distribution of color, I can add power 2 here, and now I can create a scatter node to scatter points on this curve based on the color attributes. Okay, and now you can see the end of the curve. We have more points at the end of the curves, so let me decrease the number of points, and also let's increase the relaxation number. To have a good distribution of points. Okay, now you can see we have less divisions at the beginning of the curve, and at the end of the curve we have more divisions. Okay, and here let's increase the radius for the relaxation. Okay, I'm trying to find a good distribution of points. Maybe 5. Okay. I think this is good, and now we have to sort the points based on the color attributes. And let me see the point numbers, and you can see here we have some problems. So let's go to the scatter node and increase the maximum relaxation radius. Okay, and now we can connect these points to create a curve with the help of an out node. Okay, and also let's create another point node to remove the color attributes. Okay, it's good. Now we can rearrange the nodes here. Okay, and now I can separate these nodes. And create a network box for them, but before that let's create a subnet from these nodes. So let me select them all and create a subnet from them. Okay. And here let's dive inside and let's create a network box for these nodes. And here I can rename it to resample. Okay. And now we can create parameters for the twist, roll, and also for the number of scattered points. So let's go back and go to the edit parameter interface and let's create an integer parameter for the number of points, pt num, and as a default value let's use some value like 30 and to float value for the twist, and also roll. Okay, and copy this parameter and paste copied relative references here. Let me copy it and paste it for the twist. And row. Okay, and for the roll let's choose 90. And also let's create a ramp here, and the type is float. Let's name it cross. Okay. And here, instead of this ramp, we can use the ramp for subnet. Okay. That's good. Now let's rename this node to Octopus. Tentacle. Okay, and let's dive inside and continue with modeling the suckers. Now you can see we have better results here. Of course we can add more division here, Okay, or maybe 50 or 40. It's good. And here we have to extrude the faces based on the width attribute. So let me multiply the values by width attribute. Multiplied by 5. And of course we have to transfer the width attribute to the faces. So let's create a attribute transfer node, and let's transfer the width attribute. Okay, let's check it in the geometry spreadsheet. And now what we have to do is to create a attribute promote node from point to primitive, and the attribute is width. Okay, and here I think we have to use 2. Let's increase the division. Okay, and maybe okay, maybe we can change the parameters to get a good shape here. Okay, and here let me delete the multiplied by 2 here. Okay, and here we have to create a output group. We just need the extrude front group. So here let's create another extrude, poly extrude. And let's choose the extrude front group. Okay, let's create the extrude front group again. We need another poly extrude node here. Let's increase the divisions for the extruded face. Okay, and I have to repeat this node here. Okay. That's good. And now we can create a point jitter node between the extrude operations to introduce some randomness to the geometry. Okay, and here we have to create a group node to convert the extrude front from primitive to points. So we can use it here, and of course we have to reduce the scale value. Okay, you can see 0.1 is a high value. So let's reduce it to 0.03 or even 2 maybe. And also what we can do here, we can use the pscale attribute. So here before that we have to create an attribute pscale, and as a value I will use width attribute. Okay, now we can choose higher values for the scale parameter, maybe 0.05. Okay, and we can do this between each two poly extrude nodes. So let's copy these two nodes and paste them here. Just to add some randomness. Okay, and finally we can use subdivide node. Okay, you can see the model here, and you can modify it easily because we have used procedural modeling. For example, I can go back and twist the model. And also we need to create parameters for the depth parameter and also for the seed value. So let's go back and go to the edit parameter interface again, create an integer parameter here, seed. Let's name it seed. Also another one for the sublevel. Okay, let's copy this parameter and paste it here. And also for this seed, and of course we can add random number to have a different number from the previous seed one. And here you have to use the sublevel. Okay, but before that, before finishing this tutorial, we have to create a holy cap node to close this gap. Okay, that's good. And let's test the network for another curve. So let's create another curve here, and let's create a curve like this, or maybe we can add a point node, and we can modify the curve. And let's connect it to the network and see the results. And as you can see, what else I can do is to modify the cross section. Okay, that's better. And here you can see you have to change the values for finding the best result. For example, I can increase the resolution, or maybe we can go and change the relaxation parameters. Okay, that's better. And this is our network for making octopus leg. Thank you for watching this tutorial. I hope you enjoy it, and I'll see you, and I hope to see you in the next tutorial.